I'm Andrew Dworschak, co-founder and CEO of Yakoa, and what we do is we protect brands across fashion, entertainment, and gaming, and beyond from the unauthorized use of their intellectual property. So we're an application-driven service, which means that while we're building on top of Web3 data, that data can be messy and non-standard. And so when we're building on top of that data, we've had to build a lot of our core infrastructure from the ground up. Today, I'm going to be walking you through that journey and the constraints that we faced in setting up our core infrastructure, as well as the compromises we've made in creating a data indexer that serves our own purposes. And so, for a little bit of context, what is Yakoa? Well, at the highest level, we index blockchains to classify infringement across Web3 platforms. Those are the three core pillars of our service. And so, as we go through that, indexing blockchains, this is pulling data from large, messy, unstructured data sources into a common framework that we can then serve to the rest of our application stack, whether that be an AI algorithm, whether that be a real-time application our clients are interacting with. This is a data engineering problem. When we're actually classifying the infringement, now we're looking at an artificial intelligence problem. And so this is taking in large corpuses of data, both the assets that our clients care about, as well as the larger corpus of every NFT that's ever been minted to a blockchain, and doing this sort of apples to apples comparison to track down these are the assets that are infringing according to copyright and trademark law, and surfacing the most relevant assets according to our clients' needs and what they perceive as a damage to their image. And then we're allowing our clients to take action on those assets. And this brings up a platform integration problem, where we're surfacing the distribution of these assets across Web3 platforms. We're showing where it's showing up. We are helping those platforms broker takedowns from their services, and we're managing the way the takedowns are accomplished across all these environments. And so this is a messy problem. There are a lot of moving pieces, and I'm working with a 15-minute talk here. So we're gonna have to dive in somewhere. Since this is Data Council, I thought a good place as any is to really dive into what it looked like to build up that data indexer and how that manifests in the rest of our product. And so to build a bit of a common framework about blockchain data, there are a few different constraints that we really need to think about. First of all, you might not expect it, but there are actually thousands of blockchains out there. So when you're thinking of a blockchain, you might be thinking of Bitcoin, Ethereum, Polygon, Solana, and it's true. There are a handful of blockchains that handle the vast majority of all transactions in the NFT space. And these are the public open blockchains that generally come to mind. But there's a power law distribution where there's a much longer tail of blockchains, some of which are important to index and others less so. When we're talking about the scale of data, we're looking at hundreds of millions of assets. And so we're looking at terabytes of data, edging into the petabytes of data. This is big data, but it's not huge data. It's not the exabyte scale. We're dealing with probabilistic transaction finality, which is a fancy way to say that the data that you get in, you're never quite sure if it's going to disappear on you. Blockchains can reorganize their blocks based on the longest chain at any given time. And so you're always making a trade-off between being responsive in your indexer and being up to date with the chain head, and dealing with deletions and data manipulation in your platform when you realize, hey, that data we just indexed actually just disappeared. And then you're dealing with a dichotomy between on-chain transactions and off-chain storage. And so the way there's sort of a discontinuity between the way that tokens are posted and transacted on the chain versus where the assets that can actually be infringed upon tend to live, because they tend to live on public websites, on decentralized storage locations, et cetera. So with that as a bit of background, how do you set up an indexer on top of this? Well, there are really three possible models for an indexer that anybody should be thinking of when they try to build something in this domain. The first is the simplest and easiest. You just do real-time computation. You run a node, the same thing that anybody is using to prove transactions and actually execute these blockchains. That is by far the most flexible method, but when you're running this real-time computation, you have no aggregation of data. It lends itself very poorly to analytic type queries. So there are a number of services out there that have started to aggregate this data for people. So they found common use cases that different companies face when they're building their applications. And they sort of provide data as a service. And so they'll typically take a small horizontal of the ecosystem and handle contracts or pull in NFTs and structure them in a way that caters to a general need. But because this data is so messy and these applications are so diverse, there's so much of a lack of infrastructure, you need to usually take it one step further when you want to get to your own application and build some kind of purpose-built last few miles, call it indexer, where you're taking the data that you can get from a provider and adapting it to your own needs. And so I'm going to be diving into what that process has looked like for us as we've gone through the indexing stand-up. And so the first and biggest consideration that we had to make right out of the gate was, what is our anchor data model going to be? When you're thinking about blockchain fundamentals, there are a bunch of different entities that you could anchor onto, everything from the chain to the assets themselves. And so when you're thinking about anchoring to a chain, you could start by namespacing everything under Ethereum or Polygon, et cetera. For us, it didn't lend us very well to the use case because as we're going through and looking at a chain, we're sort of chain agnostic. We care that there is infringement happening in the ecosystem, not necessarily which chain it's under. So you could go one level deeper and look at the contract. This is the code execution environment where all of these different assets and entities are being hosted and being run. This is better, but it's not actually the entity that's being transacted upon. That is the NFT token. And so when we're looking at an NFT token, that lends itself much better to a core data model that we can anchor everything around. But we're working in a bit of a different use case where we really care about the assets sitting behind the scenes, the images, the text, the media, the metadata, the animations, the 3D models, you name it. And so what we chose to anchor our data model around was the asset. Now, this sounds like a reasonably simple choice to make that might not have terrible ramifications, but it is an important consideration because each of these concepts is kind of discontinuous. There are little wrinkles and complexities in joining any one of these data sources into the next that force you to make a lot of compromises and really challenge the assumptions that you make as you build that indexer. And so I'll walk through a number of the real-world constraints that we've faced in setting up our infrastructure in the hopes that you can translate them to your own use case. And so looking at that sort of chain to contract discontinuity, a blockchain is very legitimately a chain. There's one event, and then the next event, and then the next event, and then the next event, and they all happen in sequential fashion. When you're looking at contracts, those are more of an entity. And so those might pop up at time X, and then later on have off-chain data get associated with that contract, and finally have an event get emitted that says, well, this contract is important. It is actually associated with an NFT that you might want to be looking at. The problem is that because the contract was published so long ago, you don't know which ones are going to be important when you first encounter them. And you have to either decide to remember everything, or you have to cleverly look back in time to be able to figure out what the contracts look like. There is a secret option C here where you can leverage these off-chain data service or these other infrastructure services that have indexed small parts of the ecosystem, because they can do this high-level contract classification, distribute that cost across a larger number of applications, so that the burden that anybody like us who's driving an application face is a lot lower. Then you start looking at, well, what's the relationship between contracts and tokens? And the way that you probably think about it is a token gets published onto the blockchain, it sits there, everybody can see it, and then it gets traded like crazy across all these different marketplaces and secondary environments. Usually that's the case, but historically, transaction costs have been really high to exchange these tokens. And so marketplaces and the different websites that facilitate this exchange have gotten clever. And they decided, well, we can list these first and post them on our homepage, see if somebody's going to buy them, and if they actually make that on-chain transaction, then things get realized into a token form. And finally, you can get this sort of widespread distribution where everybody can index it and list it on their own marketplace, et cetera. This creates a very large problem, again, because a marketplace listing is something that has a lot of attention. It does affect a brand. It does affect our clients. And so we need ways to be able to bring in that information adjacent to our other blockchain data sources. So that forces us to relax a lot of the constraints about the data input environments that we accept And it also forces us to just accept the reality that we're never going to get 100% coverage. There are always going to be some long-tail data sources, some more obscure marketplaces where we can't reliably pull in the information into our system. And then you start thinking about tokens versus the assets themselves. And as I mentioned, this is the dichotomy between on-chain storage of tokens, where all the transactions are taking place, and the place where the assets are actually stored, which is usually off-chain. And that also creates a number of problems. One is silent updates. And so what you'll often see is that there will be a token sitting on a blockchain that has a pointer to it. It says, there is an asset located at mywebsite.com. And I have no idea what I'm going to get when I actually fetch mywebsite.com. And so I can do that, and I can check what it resolves to. But if that website then decides to change the asset, maybe they take the image and swap it out for another image tomorrow, that's often a silent event. It doesn't propagate back up to the blockchain. And so there's a bit of a time dependence on the time that I actually query the blockchain to find this data. There's also indefinite retrieval failures. When you're dealing with these off-chain storage systems, one of the major problems you face is that there's never a definite this data does not exist event. You sort of query hash tables on and on and on recursively until you either get bored or figure that things are getting too expensive. And so just by the fact that you don't have data doesn't mean that data doesn't exist. It just means it was hard to get. And frankly, these storage systems are just slow. They're totally unsuitable for any type of real-type indexing and application. And so this forces you to create a secondary layer. So now you have the tokens, which are disjoint from the assets, which are disjoint from your own caching layer of all this information that you can make your decisions upon. And really, there is no silver bullet to addressing this problem. It's immensely difficult and messy, and hitting the longer tail of all these assets is generally infeasible. But there is a silver lining here. The harder it is for us to go and find these assets, for us to retrieve things and cache things and keep them up to date, the more difficult it's going to be for every other environment in the ecosystem to do so as well. And so because of this, it's going to be less visible to the users, less effective or less impactful on our brands. And so in some sense, the stuff that we get first is going to be the most important stuff, and we can keep on extending that chain from there. And so rolling this back up to the bigger picture, we've been able to take this data indexer, and it has powered the core of our service. And so sitting at the core of the service, there's that indexer, and that allows us to pull in all of the assets from our customers. It allows us to apply our AI to these systems, detect infringements, and stack rank what our customers care about most. And allows us to really dig in, monitor the ecosystem, and broker these ecosystem-wide takedowns and resolutions. And so the real lesson that I think is important to take away from all this is that just by having this indexer, And so the lesson that I think is most important to take away from all this is that when you're working in this messy data environment, it's never going to be possible to build the theoretically perfect system. You're never going to be able to capture every long tail assumption. You're never going to be able to capture every data irregularity. But if you're deliberate about the compromises that you make, and you're confident leaving the door open to evolve to future standards as new standards evolve onto the chain, then you can still deliver a polished and valuable experience to your clients. Thank you.